Okay, hello. Thank you for joining. Today's session is covering how SD WAN makes cheap internet faster, safer, and more cost-effective. We're going to cover what SD WAN is and how it matches against traditional setups. And we're also going to talk about four key benefits that we found that will help clarify how we see utilizing this methodology makes it for a win. My name is Jason Etter, and I'll be moderating this discussion. And we'll be learning from our VP of Consulting, Jayesh Davi, on his experience with Ripple's best practices. Jayesh, thank you so much for joining.
Thanks, Jason. Appreciate it.
You got it. And so just a little logistics before we get started. Yes, this is being recorded. We will save some time for the end, but I wanted to just point out that there is a chat and a question section. Ideally, the question section. We'll be monitoring that throughout the conversation. If you have a question, just simply write it down, and we'll either address it during the slide if it makes sense to break, or we'll address it at the end. And of course, if any question doesn't get answered until because of time, we'll reach out to you directly and make sure that we get you that answer. Okay, so let's get started. Friendly reminder one more time, this is being recorded, and we'll make sure you get a copy of it after the fact. So let's get started. Let's just go with the most obvious question, Jayesh. So what exactly is SD-WAN, and frankly, why should I care about it?
Hey, it's a great question, Jason. SD-WAN, in a nutshell, is a technology that allows you to utilize commodity and inexpensive internet circuits to provide a secure, cost-effective, and resilient network environment for mission-critical applications, mission-critical cloud applications. And it's a very important piece of this, is that it doesn't have to be on premise. It can be off premise. It can be in the cloud. So it's very flexible, and it allows you to spread the resiliency across all of the different locations where your business critical stuff would be.
Excellent. And if you just for my own understanding, that when you say circuits, you mean whoever I'm working with, like Verizon, Optimum, whatever it may be. Is that what you're talking about?
Yeah. So basically, it's your ISP, right? So today, a lot of times when you talk to people about delivering critical services over the network, you hear stuff like MPLS, and then you all of a sudden start to see dollar signs. So really what we're talking about here is, how do you leverage great commodity internet options these days to be able to deliver a mission critical environment? So really, SD-WAN goes to the crux of that.
Excellent. Thank you. Okay, great. So perfect. So you talked about MPLS, but with that, I've also heard that a lot of folks like to use VPN to connect offices. And I was wondering if you could use that MPLS or the VPN example to really clarify what that is and how SD-WAN might actually be different.
Sure, absolutely. So, traditionally, MPLS and VPN were terrific ways to connect the offices. They each provided their own benefits, which we'll get into. And they allowed you to deliver centralized services like VoIP, ERP, and whatever else from maybe a primary data center or primary location. VPNs are great because they're cheap. Most everybody these days has a firewall and is connected to the internet. Therefore, you can utilize those two things to connect the offices. So it's rather inexpensive. If you have two circuits, you can do an active-passive failover type of thing. So you do get some level of redundancy. In terms of MPLS, it's a little bit more costly, but the cool part about that is that the carriers were able to give you kind of a service level guarantee. They were able to guarantee the bandwidth and the latency, and it was all part of an SLA. If you had two MPLS circuits, or if you had a backup VPN, then you could also provide redundancy if you did some interesting things with the routing and whatnot. SD-WAN is somewhere in the middle. It's of those two solutions. It allows you to take some cheaper internet solution or internet circuits like we talked about, and gives you the ability to control the applications and how they flow across it. It gives you the ability to police the traffic. So it really kind of works to blending the best of both worlds. Cheaper circuits with the control and the quality that you get out of MPLS. And the cool part is it doesn't stop there. So in fact, let's take a look at an example. I mean, we could probably get into a lot of different scenarios where SD-WAN really outperforms the two of these. But let's talk about one that's a pretty straightforward example, right? We said that you could protect traffic that's both on-premise as well as in the cloud. So let's take an example of a cloud situation. For example, voice over IP using Vonage. Now, in many cases, what you'll have is you'll have somebody deploy the Vonage voice over IP phones in different locations. They'll set up an active passive internet connection. So should anything occur, you have the secondary internet, yeah, et cetera. But let's kind of walk those down, the different scenarios that we see. So one is, like I just alluded to, active passive internet. So you get the edge firewall, you set up the two different internet connections, you're good to go, right? For data, that works like a champ because it'll fail over, nobody's the wiser, and you're able to continue to work. This has a lot of shortcomings when it comes to voice. So what happens when one of your primary internet circuit goes out? Well, your IP changes. So even with a quick failover or what have you, you still drop your call, your phone still have to re-register. And this could get even worse if you just have bad line quality. So forget about a true failure. You actually have a scenario where the line quality, the jitter gets high, the latency gets high, and the circuit never truly fails over. Now you have your team, either your tech team or whoever you have to open up a case with. They're going in there trying to diagnose, well, why is the quality poor? So that's active passive. So then another scenario that we see a lot of is you have two different ISPs and you use some sort of routing to balance them. Typically that's BGP. Internet drops or becomes unstable, and you have very similar sort of things, right? So if the internet drops on the primary circuit, the failover time is such that even if your timers are very aggressive, you would still drop the phone call. So again, the net is the same result, right? You're not able to survive a failure. In terms of degradation, it looks the same as active passive, right? If the routing protocol doesn't catch it, well, it's going to sit there and allow it to flap and do other things, and you're just going to have poor voice quality. Now, let's take a look at an SD WAN solution in either of these scenarios. If you had two sources of network connectivity and you had an SD WAN device behind it, what you'd be able to do is you would be able to, one, survive a failure because you're using both of the paths simultaneously. It does a per packet steering, and it gives you the capability to pin the traffic on whichever one works the best. So that's terrific. If you think about it, if it's going to be able to use both at the same time, how does that actually work? Because we just talked about an active passive scenario where you had two different IPs. So we use, in this case, we deployed VeloCloud, and we use what's called their public gateways. Their public gateways are basically clusters and data centers that have one IP. Doesn't change. So even if your circuit, you went flip-flopping between your two circuits, your public IP from which your phone is registering or you're heading out to any of these business critical apps does not change. So therefore, you're able to fail a circuit and still be able to maintain the call, to maintain the registration. Nobody's the wiser. So it's a great user experience. Now let's take a look at the degraded circuit. The degraded circuit is also very interesting. So nothing's failed, but one of your circuits starts to see, jitter, latency, what have you. We use forward error correction and jitter buffering on the VeloCloud device in order to improve the circuit. So in a lot of times you'll see a circuit performance that's actually suboptimal get corrected by using some of these different techniques. So in both of the scenarios where you had either voice quality issues and or a loss of the call, SD-WAN was able to survive that and allow the user experience both for your clients and for your internal folks to remain awesome.
I really like that example, especially with voice, because it's nothing is more clear to me than when I'm having a conference call, whether it's whether it's internal or with a potential client, and if it drops, it's just devastating for the flow, for just the meeting itself, and it's frustrating to no end. And so that example is great. One other thought too is, you mentioned this when you were giving the example, is just to be clear, this isn't just about a phone line. This could be any business critical application, right?
Absolutely, absolutely. I mean, this can be any of the public cloud apps. This can be apps you run out of your data center. This could be, voice that you run out of your data center. I mean, we did a deployment like this for a client that had to centralize a VIA system. We did a deployment for this for a client that had a centralized, or they have an AS400 that all the plants report back to. So yeah, I mean, it doesn't matter. It's just you have to, if you categorize, hey, real-time data, real-time mission critical apps, that's when this really starts to make a lot of sense.
That's great. So let's dive a little bit deeper then. So what we did is we took together some thoughts around this, and we put together some key benefits of using this methodology, and we're going to walk you through. But before I do that, I just want to ask, I think there's a question that I'm sure a lot of folks are thinking about, which is, Jayesh, how expensive is this going to be?
That's a great question. No, it does sound like it would be pretty expensive, right? But this is kind of where the real magic of this whole solution comes into play. By using commodity internet circuits in combination with the SD WAN technology, you're really able to drive down the cost pretty significantly, especially if you're coming from MPLS. So today, a lot of what we're seeing out there is folks coming from MPLS. Well, MPLS was so expensive, they have one connection and they don't have everything else to make that really resilient. So they're spending a lot of money. Yes, they're getting a guarantee from the carrier, but that sometimes doesn't equate to a lot. So when you can tell them, hey, look, you can have resiliency, you can you could do all these different things. You could get performance. You could probably increase the bandwidth significantly, and I could drive down the cost. I mean, it starts to become a pretty compelling argument. The other, I mean, for active passive internet, if that's what you have and you're using VPNs, probably not going to save a lot of money, but you will be able to leverage both circuits at the same time, which is a little bit more complex if you were doing an active passive internet setup on a firewall. So at least you get that. So I mean, you get to leverage your investment. In fact,
And what, just to interrupt real quick, sorry. So, and just to make sure I'm understanding too, is when you're talking about the active passive example, and even if the cost structure is lateral, it's really the value gain here is that with the active passive setup, meaning normal traditional setup that you talked about before, I have two circuits, I have a phone line, public internet. If I have an outage, there's going to be those calls that are happening at that time are going to drop, and they will be. Then there's time also for that failover to occur, so that the second line will be up and running. And the argument here is, even if it is a lateral purchase, that drop will not happen. So that is the gain instantly, if I'm not mistaken.
That's right. That's right. And then the second part is that there's no more this concept of active and passive internet, right? They're both active all the time. You're utilizing both of them. In fact, you can use the policing, and we're going to get into this a little bit later on, but I'll go ahead and jump in right now with it. I mean, you can use the policing to actually leverage both the pipes in, and direct traffic, et cetera. So there's a lot of flexibility gained. You also, I mean, depending on what the two circuits are, you could double your bandwidth or better. So there are some benefits there. If you're just looking at strictly from a dollars and cents perspective, chances are it's not going to be cheaper. However, the benefits may outweigh that depending on your business case. So.
Absolutely. I mean, if you're trying to, yeah, absolutely. I agree. Perfect. So let's talk about these 4 key benefits. So I think the first one that we wanted to touch on was security, which that alone, we were talking about this beforehand and putting this deck together. You were going through some layers of security that I think a lot of folks, there's a misconception of what people think they have for security when they're using, especially when they're using public internet. And I didn't know if you could touch on that, and then also just how SD-WAN in general is substantially more secure than most setups that are more businesses are familiar with.
Sure. Yeah. So, but before we dive into that here, I'll give you a fun fact that'll kind of lay the backdrop for this conversation, right? So, did you know that if you plan on accessing the Department of Homeland Security for some sort of EDI, meaning electronic data integration or transfer with them, that they have an MPLS option, right? And it leverages Verizon as a carrier. Now, you would think, oh, yeah, leveraging Verizon, utilizing MPLS, slam dunk, right? In addition to that, they make you run AES 256 VPN over the top of the MPLS. So why is that important? Why is that interesting? I mean, obviously it's the government. I'm sure they have very stringent requirements, et cetera, et cetera. But it's just kind of the interesting part about that is Verizon will attest to every security acronym under the sun. But this is kind of a reminder of if you have the ability to control the data from endpoint to endpoint, even if it crosses over what you would think is a secure medium, either in-house or MPLS, et cetera, you should probably do that. So it's pretty neat, and that's what SD WAN really delivers. I mean, around a lot of the questions you asked there. So it uses IKE2 and the certificate authentication to keep all the tunnels secure. But the part where this really becomes a slam dunk for organizations is if anybody's ever set all that stuff up, they know it's a pain in the butt to keep and maintain. And that is one of the biggest deterrents to security, right? And people aren't scared because it's too much of a pain. There's too much overhead to keep it. The cool part about this is that it's built in. You don't have to wrangle it. So that's pretty neat. And it helps with the adoption, right, of just utilizing more secure protocols over different networks.
That's excellent. So, and then when you're saying the encryption end to end, you're gaining that. Whereas even if there was a perception that the vendor that you're working with has encryption, you're gaining another layer of control where you have control of what exactly is coming and going versus entrusting someone's word, essentially.
That's absolutely right. Yeah. So when you attest to, the data is encrypted end to end, for sure because you control both sides of that endpoint.
That's great. I like that. Excellent. So the second is just, and we started to touch on this, was just the performance. And this seems to be a big home run for many reasons, but really just the idea that the true utilization of both lines. Whereas I would assume many businesses, I know a lot of companies that I've talked to in the past, yes, they absolutely have two lines, and that is important. If one fails, the other picks up, and ideally you want to have two different ISPs providing that line from two different types of pipes, right? And so if one goes down, the other one will go up once the failover completes, or you try to make it as automatic as possible. Whereas I think what you're going to talk about here is an even better experience.
Yeah. So, I mean, the best way to kind of drive this home is go back to the user experience when one of the circuits gets degraded, right? It's not completely unusable, but it's degraded. So at that point, having the second circuit active allows you to really kind of buffer that. So if the error correction and the jitter buffering is not able to correct that line, you have a second source, and it's steering the packets down the second source. So now at that point, it's making the intelligent decision about the two. So that really starts to drive home how this can become mission critical. Now, as far as the performance part of it, right, by using both of them actively, I mean, it's very common to see, 20 meg, 50 meg Ethernet, fiber-based, Ethernet-based DIA or internet access circuits, right? But then what's the secondary? The secondary tends to be like a 150 by 25 Comcast or some sort of cable type circuit, which is asymmetric. Now, you may not want all your web traffic to go over your 20 meg, expensive internet, fiber-based internet circuit. You may want to send it the other way. By using it in an active fashion, you get that ability with very minimal amounts of messing around with it and maintenance on it. And then, of course, obviously the failover and the error correction stuff is included either way that it goes. But so it kind of gives you a glimpse into what you're able to do with it and how much extra bandwidth you're able to utilize out of your locations.
That's great. And this next one is the policing that you're able to. I'm sorry, the quality of service is something that allows you to just have a better understanding of what is accessing the information and being able to even provide as granular as detail as possible so that you can continue to tweak in the long term. This seems to be something that's a pretty big win as well.
Yeah, absolutely. I mean, so when you start to talk about mission critical data and then the argument for MPLS, it was always around QoS and
Mm.
guarantees and all those different things. So now with the way that the internet access has evolved and the this technology, you have pretty close to the same level of ability. Now, granted, yes, it is still over the internet. It's still, an indeterminate medium. Yes, it's going to go different routes, different ways, etc. But what we've done is really work um, to minimize that. So the way that VeloCloud does it, for example, is we have these public gateways. So when we connect into the public gateways, it's pretty determinate, and they reside close to, meaning, so like for example, Ashburn, Virginia, they reside very close to the AWSs and Azures and all the different other public cloud things. So what you're able to do now is start to policy your traffic to go in places that makes the most sense to get to the resources that it needs. That's the same thing if you look at like a 16 site, let's say you have a 16 site network and you don't use public cloud. It's the same sort of thing. Like you may have a data center that runs primary for some application, the voice runs out of another place. You're able to set up the network in such a fashion that it's always going to be the most optimal path. So prioritizing, you mentioned in the slide, prioritizing the internet traffic. Well, I mean, again, we talked about being able to send the internet traffic out, just standard internet traffic, Google, Pandora, things that, you don't want taking up very precious resources. You're able to send them out a certain way, and everything that you want to protect, you're able to send out in another way. So it's all application level, which means you don't have to remember a bunch of IPs, this, that, and the other. I mean, it's pretty neat. And then the reporting part of that allows you to further tune it, right? So you're able to look back at a week, a month, a day, 60 minutes, and understand what's going on and what's traversing your network and how it's leaving your network. And then you can modify the behavior as you see necessary. So it really it's an extremely high level of visibility and a high level of tuning that can occur on these devices, since you control the data flow on both sides of the pipe.
One of the things that we were talking about earlier in our internal discussion before doing this was about the policing and being able to just get super granular about what applications, et cetera, should have the priority. And I wanted to ask about, if I was, let's say it was a one-time situation. I've actually had clients that have had ads ask this of us is, hey, we have this huge conference coming up, or a really important meeting happening on Friday. Can we just make sure that under no circumstances will anything prevent us from making sure that this room, this streaming service, whatever it is that we're using, is going to be the priority? And so if Chuck starts downloading Game of Thrones, like, that's not going to throw us all into a tailspin.
Right. Absolutely. So yeah, it's super simple with the cloud orchestration. It's just a matter of probably 6 clicks, and you can have that rule at the top. You can make sure it's prioritized to use 90% of available bandwidth, and then that will basically choke out anything else. So nobody will be able to download Game of Thrones.
Even if it's something, even if it's something as simple as like a temporary, like, I just want absolute
Yep.
assurance for this one meeting, and
Yep.
then we can set it back. That's great. So, and it's 6 clicks away. That's not bad. That's great.
Yeah.
Excellent. So the other part of it too is redundancy, and I think this is something that I'd love to hear a little bit more about, because it's part of, I think, of all this part. This is the part that I'm the least familiar with, and I'd love to get some more insight into that.
Certainly, yeah. So redundancy. I mean, we talked about it briefly, I guess, in some of the other parts of the discussion. But really, I mean, again, you have, so your MPLS circuits tend to get delivered over fiber or over Ethernet. They have a much higher level of resistance to outage, things of that nature. The internet circuits these days you can get will allow you to do something similar, over fiber, over Ethernet. And then your secondary circuit can be anything commodity, and you can probably even have a tertiary circuit, which is cellular. In a scenario like that, with the way and the granular level of control we're able to fail between the different sources, you could provide a pretty much MPLS like SLA on the resiliency, on the redundancy, without all the craziness that goes into the routing protocols and making sure things converge properly and this, that, and the other. So yeah, when you talk about redundancy, it's redundancy, it's easy, it's redundant, it's easy, and it allows you flexibility in terms of where you put your critical resources. So the removing of the fear of the outage is actually is huge. I mean, it doesn't make it cost prohibitive for you to be able to have kind of mission grade stuff. So it's to not belabor the point, but anytime you get into this discussion, the first thing MPLS folks like to say is, oh no, they can't provide the QoS. You're right, because it goes over open internet pipes. It's very hard to quote unquote provide the QoS. However, with the internet that we have today and your ability to use both pipes simultaneously and duplication of the packets, etc., you're able to get it pretty darn close to that type of experience. So it's a huge win.
That's great. And so if I'm a business owner and I'm looking at my monthly bills, quite frankly, and I'm going, gosh, why rarely do I go out, do I have an outage here? But when I do, I have this backup, and it's okay. So the argument here, if I'm not mistaken, is that the gain is there is no more worries about that extra cost, because you're utilizing both at the same time. You're prioritizing how it can be used. And then when there is an outage, you still have that secondary option, so that they're both kind of working in tandem as things are going through.
That's right. That's right. Yeah, I mean, yeah, you summed it up well there. I think I was a little bit more verbose.
This is good. This is good. So I think that let's just recap, and I think we're going to answer a couple of questions and talk a little bit further on this. So the short version here is you get the control back. I think that's one of the main points that you made, JS, really well, is that you talked about when you're working with your ISPs, and regardless of how the promises and the documentation you may have to make sure that certain compliances are met, etc., you don't really truly have that control. You still would need to request proof, etc. In the Department of Homeland Security was a perfect example that even then, in that situation, they still want that extra layer of control for themselves. And if you have that available to you, why not take advantage of it? The overall bandwidth win, I think this was something that I was trying to discuss a little bit further in the last slide, but I didn't do a great job of it. But you do win more bandwidth, right? So instead of having two separate lines, or when you were talking about active passive, you have two lines working together as one, making a better connection overall. And I think actually you gave a good example. We were talking internally that you could really just crunch the numbers and say and get a heck of a lot of a better connection, if I'm not mistaken.
Yeah, absolutely. I mean, again, it comes down to costing, especially if you start talking about places that are kind of out of the way a little bit, where they're not as well lit. You could tend to get, some pretty cheap stuff in there, or not. Let me not say cheap. Let me say you can tend to get stuff like DSL and cable in there, or even low latency satellite, but you can't, or fixed wireless, but you can't really get the fiber-based option. So now what you have to do is figure out, how do you take that mix and be able to still deliver mission critical stuff over it. So yeah, I mean, when you start talking about active for all your circuits at any given time, yes, you really start to win when it comes to bandwidth, et cetera, and just making it much less cost prohibitive to be able to have high bandwidth and the redundancy.
And then this right here, right? There is a constant struggle when you're, especially in this age, right? Organizations are completely dependent on applications to run their business, whether it's in the cloud or whether it's locally based. Making sure that that prioritization is set is absolutely critical to ensuring a successful day. And when there is a fail, it could be completely detrimental. And so being able to really have those prioritizations that you talked about in place is a pretty substantial step forward.
Yeah, absolutely. And with the way that the cloud orchestration occurs, it's just a profile setting, and you can deploy it to anywhere from 1 to umpteen sites. So it really starts to allow you to get granular, to rinse and repeat, and do it in a way that doesn't take days and days and days or months, to do. You can actually do this in a very quick fashion. So it really it offloads a lot of the headaches in terms of the day-to-day management in order for you to be able to deliver the prioritization to your apps. So it's strong in that regard.
That's great. And then just, again, the core message from the beginning here was really, if you're paying for 2 lines and only using one at a time, I mean, that alone is just, it's certainly a home run. And I love the idea of being able to encompass all 4 of these aspects together. The value seems to be pretty clear. And we also wrote a pretty hefty blog on this as well, and be happy to share it with you with all attendees after the fact. But wanted to see if there was any questions specific to this. If they had any more questions, and then we can call it. Let me just take a look here. Do have one question that was about the cloud. You mentioned a couple of times that there are, through VeloCloud, you're able to actually leverage things like if you're using AWS or things of that nature. Could you elaborate a little bit more on what that means? I think because it could be a little misunderstood or confusing.
Yeah, absolutely. So the public cloud or the public gateway architecture that VeloCloud has, they put these in these different data centers that are very close to where most of the cloud stuff lives, right? So I gave the example of Ashburn, Virginia. That's very close to the presence on the East Coast for AWS and many other SaaS and IS providers. So if we wanted to break that down from your site, if your site has 2 network connections and we deployed a VeloCloud there, basically if we protected that traffic, it would loop up connections to the public gateways that are in Virginia. At that point, like I said, you're pretty close, most likely in the same facilities, and we would be doing a VPN from their cloud into AWS, do a VPN from their cloud into Azure, whatever the case may be. So what it does is allow you to, again, protect that traffic with a very, very minimal headache in terms of setup. All you're doing is doing it through business priority. You're saying, hey, look, these are my prioritized apps. It'll automatically create the tunnels. It'll automatically protect the data, and it gets you up to the most optimal path. So that's how that looks when you start talking about public cloud. You could do the and you could do the same thing, obviously, for your internal stuff, whether it's over MPLS and internet or just over internet. I mean, we can. There's a lot of flexibility in terms of the architecture.
Great. There's another question here about actually, is there a cap? Like, is there a max combined bandwidth that is actually supported?
Yeah, so right now with VeloCloud, I believe the largest device that they have is a 2 gig device, which basically means 1 gig down, 1 gig up. And the way that we would scale that out if there was more data throughput needed is we would start to create active cloud gateways, and they would handle it themselves. So you would never overload one of them. They would be able to, we have a dynamic routing protocol that's proprietary internal to the box that would handle all of that.
Okay. Another question here was about ISP connections. Can you, is it just 2 or can it be more? Is there a limit?
Can be more. No, it's platform based. So if you want more than that, we're gonna 2 is at the lower end in terms of the devices. As we start to go up in the platforms, then we can get into more. So yeah, we have clients that have done 3. So I mean, there's I think a capability to do even more than that. So
excellent. That's great. That helped me out quite a bit. What we're going to be doing, Jayesh, any closing thoughts before we call it?
Yeah, not really. I mean, we touched on, I think we touched on a couple of different models there in terms of the public cloud hybrid or the or local. I guess the biggest take home point is that it is extremely flexible. So if you're thinking about looking at this route or thinking about how this can help you, it's probably worth a discussion just to figure out, where it fits in your environment, what it would look like to integrate. Don't just count yourself out feeling like you're in a bad technology spot. I think there's a lot of different ways to make this play in different environments.
Excellent. Jayesh, I really appreciate your time. For all of you, you'll get a copy of this webinar. I encourage you, if you take a look at the chat, I dropped in a link to our blog post. I'll be updating that shortly with the video. And of course, if you have questions, please feel free to reach out to us. We try to make this long discussion easy to digest, but we welcome any type of complex environments, questions, etc., that are interest of you, to see if we can figure out a way to solve around that. Please reach out to us. We welcome those conversations. Thank you all, and have a great day.
Thank you.